let's work through an example together. So we have a large planar boundary between two different dielectrics. So why don't we draw a diagram first so that we can save some time while doing this. So we have a large planar boundary between two different dielectrics. We can just draw a straight line to represent this boundary. Let's call this the planar interface. Let's call this medium 1 and this medium 2, and they're both dielectrics, it seems like. They're both different dielectrics with an absolute permittivity of epsilon 1 and epsilon 2, and we know that epsilon 2 is greater than epsilon 1. The electric field is incident in dielectric 1 with an amplitude E1 and an angle of theta 1 with the normal. So let's draw a normal to the planar interface. So it's normal. We have the electric field coming in incident at an angle theta 1 with the normal. So we've drawn that. It says there is no surface charge on the boundary, so that means at the boundary there's free charge of 0. We're going to now try and answer the following questions in dielectric 2, so underneath the boundary. Is the angle theta 2 larger or smaller than theta 1? So we don't really know how to draw this yet, so we're going to have to do some analysis. For part A, we're trying to figure out if theta 2 is larger or smaller than theta 1. So because there is no free charge at the boundary or interface, so we can use the normal boundary condition for dielectrics and say d1n is equal to d2n. We know that the electric flux density D is equal to the absolute permittivity epsilon times the electric field, but we know that d1n is equal to d2n, so we set them equal to each other. We have epsilon 1, which is the absolute permittivity of medium 1, times E1 n is equal to epsilon 2 E2n. So right now I already know what E1 is. I've drawn it. I now want to figure out E2. So if I want to figure out E2, it means I need to figure out whether it's going to be smaller or bigger or some sort of comparison to E1. So then E2n is going to be equal to epsilon 1 over epsilon 2 E1n. So what is E1n and E2n? Why don't we draw these out? For E1, this would be E1n, and this would be E1t. So looking at this comparison, E2n is equal to epsilon 1 over epsilon 2, some sort of ratio of E1n. We're given that epsilon 2 is greater than epsilon 1. So that means we have E2n being smaller than E1n. right? So with this, I can at least draw an E2n that's smaller than my E1n. We should probably do an analysis for E1t and E2t as well, but for the tangential boundary condition, we know that at the boundary, E1t is equal to E2t. So now I can also draw this out. It'll be the same length as this. So we have E2t going this way. Now I'll be able to draw my E2. So with E2, I have this here, and both of these are vectors. And how do they compare with each other? Let's take a look. So this is going to be theta 2, and this here is theta 1. So clearly from the diagram, we can conclude that theta 2 is bigger than theta 1. Now part B is asking us to calculate the value of E2 and theta 2. So we need to find E2 and theta 2. And this is going to be fairly straightforward. We know that E1t is equal to some trigonometric function of theta 1. It's going to be E1. So sine of theta 1 is equal to opposite over hypotenuse. So sine of theta 1 is going to be equal to E1t over E1. So if I want to figure out E1t, it's going to be equal to E1 sine theta 1. We also know that E2t is going to be equal to E2 sine theta 2. But with the tangential boundary condition, we know that E1t has to be equal to E2t. So therefore we have E1 sine theta 1 is equal to E2 sine theta 2. And we call this equation 1. So that was the first step. Next step, let's take a look at E1n and E2n. E1n is going to be E1 cos theta 1. E2n is going to be equal to E2 cos theta 2. It's pretty straightforward. And we try to solve for E2n, just like before. So we can just copy that down. E2n is equal to epsilon 1 over epsilon 2 E1n. But we know E1n is equal to E1 cos theta 1. So let's replace that. And this we'll call equation 2. So what we're going to do next is divide or before we even go about doing this, let's take a look at those two equations and try and figure out how to find E2. If I want to find E2, that means I need to somehow get to here. So the best way of doing this might actually be to divide the two equations, or you could plug one of the equations into the other. In this case, it's not really clear what I have to do because I haven't finished substituting my E2n here. So why don't we simplify this? We have E2n being E2 cos theta 2 is equal to epsilon 1 over epsilon 2 E1 cos theta 1. And that should be our second equation. So now that we have everything fully in terms of E1 and E2 with none of the E1t's or the normal components, we now solve for E2. So to solve for that, it is easier to divide the two equations together so that we get a tangent function. So we divide 1 by 2, and that means we get, so we have E1 sine theta 1 equals to E2 sine theta 2. I'm going to put all the 1's on one side, so epsilon 1, epsilon 2, E1 cos theta 1 is equal to E2 cos theta 2. And dividing the two of these, I have epsilon 1 over epsilon 2 tangent of theta 1 is equal to tangent of theta 2. And to solve for theta 2, it would simply be the arc tan of epsilon 1 over epsilon 2 tan theta 1. Okay, so we've solved for theta 2. Now it's time to solve for E2. So to find E2, we can actually square both the equations. And when we square both the equations, we get E1 squared sine squared theta 1 is equal to E2 squared sine squared theta 2. The second one, we have E2 squared cos squared theta 2. Let's just rearrange this first. We have E1, epsilon 1 I mean, square that. E1 squared cos squared theta 2 1 is equal to E2 squared cos squared theta 2. Okay, so looking at the two of these, it might be easier to just add them together because sine squared theta plus cos squared theta is equal to 1. So let's just add them. So then we have E1, which I can factor out. So I have E1 squared sine squared theta 1 plus epsilon 1 epsilon 2 squared cos squared theta 1 is equal to E2 squared sine squared theta 2 plus cos squared theta 2. So here, this is simply just going to go to 1. And then I can solve for E2. And E2 is going to be the square root of a really long term. So the square root of E1 squared is E1. And the rest is going to be sine squared theta 1 plus epsilon 1 over epsilon 2 squared co-squared theta 1. And that is your answer for your second medium's electric field.